If human beings ever inhabit another world in our solar system, this is the most likely candidate: the red planet, Mars. To a visitor from Earth, a tour of Mars might be very reminiscent of places back home. Places like Southern California's Mojave Desert, geo and astrobiologist Ken Nielsen finds this desert area so much like Mars, he comes here to try to better understand conditions on the red planet.
You travel around here in the dune buggy and you see features that look just like the dune features on Mars. If you go further and look in the background and see all of these red hills full of iron oxides that we see on Mars, Mars is filled with iron, and its oxidized iron, basically rust, turns into dust particles. And in addition to the beautiful dunes, you have this red atmosphere, sometimes red all over the surface of the planet. Huge dust storms. They don't call it the red planet for nothing.
But while much of the Martian terrain is similar to Earth, some geological features dwarf any of their kind on our home planet. A mountain named Olympus Mons, Latin for Mount Olympus, is the tallest known peak in the solar system. It's a now dormant volcano that rises 15 miles above the Martian surface.
If you draw a picture of Olympus Mons and put it next to Mount Everest and the big island of Hawaii, even taken all the way down to the base of the ocean, they look like molehills compared with Olympus Mons on Mars. That mountain is so large, you could be on its slopes and you would not know that you're on the slope of a volcano because the base is so huge before you get to its summit.
Yet, as awe-inspiring as the Martian surface appears, it is a brutal, inhospitable zone for human beings.
6 green board, 5, 4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
It's cold, it's dry, it's desolate. There are dust storms that can darken the skies for weeks or even months at a time. It goes down to 100 degrees below zero at night, every night.
Compounding these cruel conditions is an atmosphere with no oxygen. Martian air and even occasional cloud formations are made up almost entirely of carbon dioxide.
So it's not a nice place. You wouldn't enjoy it if you went there.
Mars is small relative to the Earth, only about half the size of our planet. And its distance from us is never less than 34 million miles. It appears as nothing more than a tiny red orb in our night sky. Even so, Mars has captivated humankind for centuries. The planet takes its name from the Roman god of war. The Romans associated this distant world with hostility and unrest because of its blood-like color and because of its distinctive movement in the sky.
Mars wanders. It doesn't do what the stars do.
The red planet occasionally appears to be moving backward across the sky, a behavior that confounded observers for centuries. But in 1514, close study of this planetary movement led Polish astronomer Nicholas Copernicus to a revolutionary understanding of the solar system.
For much of recorded history, people thought that Earth was at the center of the universe. So along comes Copernicus, and he says, no, maybe the Earth isn't at the center of the universe. Maybe the explanation for all this is that things are going around the sun. And if all the planets are going around the sun, then we can explain why, as Earth passes Mars in the orbit, Mars begins to wander in our sky. It looks like it's going this way, and then it starts to go this way.
By the time of Copernicus's observations, Mars and the Earth had been passing each other in their respective orbits for some 4.5 billion years. Time enough for the two planets to have evolved into very different worlds. One warm, wet, and oxygen-rich. The other cold, dry, and oxygen-depleted. Yet it's now believed that the differences weren't always so stark. Scientists today think that Mars was once warm enough for large amounts of liquid water to flow across its surface.
When we look at Mars today in our best satellite images, they tell us the same message we heard with the first missions to Mars, and that is that there's no liquid water on the planet today. But there's virtually incontrovertible evidence that there was water there in the past. Everybody knows that when water flows through any sort of dirt, there are characteristic structures that are a function of that water running through. And when we look at the pictures of Mars, the satellite images, we see very similar structures leading us to the absolute conclusion that Mars was once far warmer and wetter than it is now.
Mars, of course, is a harsh desert today. So what could have happened? What cosmic processes could have brought about such a dramatic transformation of the fourth planet from the Sun? The story begins with the origin of the solar system. Somewhere in the range of 4.5 billion years ago, our solar system sprang from a supernova, a stellar explosion emitting a swirling mass of molecular particles and gases. This swirling mass, or nebula, began to cool, and as it did, it condensed and separated into rings of particles. These particles began to accrete, or gradually clump together to form planets. The accretion process creates heat, and heavier particles sink to the center of the accumulating mass. So Mars eventually formed a molten iron core. This churning molten core generated a powerful magnetic field. The field projected outward, surrounding Mars like a protective shield, blocking harmful emissions from the Sun.
You have this constant pressure from the sun, which we call the solar wind. The solar wind is made up of protons, electrons, cosmic rays, all of these kinds of charged particles that could ionize the atmosphere, as we call sputter it away.
But eventually, Mars lost its protective shield and most of its atmosphere. The moment the accretion process ended, the planet began to cool.
The iron core was no longer able to generate this magnetic field, and then the solar wind started pounding the surface of Mars. That's a scenario that a lot of people believe.
The loss of atmosphere stripped the Martian surface of warmth and pressure. And since water needs both warmth and pressure to remain in liquid form, water is no longer stable on the Martian surface.
You put a pan of water out on Mars, it's going to evaporate very fast and try to freeze at the same time. One or the other will win out, but you won't have a nice liquid pan of water.
That's not to say, however, that there is no water on the planet at all. While liquid water is no longer stable on Mars, frozen water, ice, is a different story. And evidence suggests that still today, tons of water ice might lie just below the Martian polar caps. Locked within that ice might just be the holy grail of space exploration. They are visible through simple telescopes on Earth. And they are unquestionably the first planetary features noticeable during an approach to Mars through space. The Martian polar caps, mysterious snowy white ice swirls sheathing the top and bottom of the red planet.
It's actually what we call dry ice, frozen carbon dioxide. The atmosphere is very thin and it's nearly all carbon dioxide, so when it gets very cold, what condenses out is carbon dioxide snow, carbon dioxide ice.
But while the white caps are certainly a colorful planetary feature, it's not the frozen concentrations of CO2 themselves that are of most interest to scientists. It's what's thought to be hidden beneath the polar caps that could have massive significance. Lurking just below the topsoil may be millions of tons of frozen water. Water ice, hidden from view, appears to radiate out hundreds of miles in all directions from the poles. And leading scientists think it could be the residue of once vast oceans.
Likely the water is now frozen in a kind of permafrost beneath the surface. But maybe there are pressures and temperatures in various areas of Mars that have liquefied the ice and created perhaps aquifers.
We can see craters, an impact has happened. Asteroid has hit Mars, blown out a lot of stuff. It doesn't blow out dry powder like on the moon and make rays and rubble. It throws out kind of a muddy slurry of stuff. So the conclusion is that you're actually impacting into ice like northern Canada, permafrost layers, tundra kind of stuff.
Orbiting spacecraft have picked up strong indicators for the existence of water ice at the Martian poles. Remote measurements of soil Water, of course, is 1 part oxygen and 2 parts hydrogen, so the possibility of ice hiding below the surface in those areas is overwhelming. But while strong evidence of ice at the Martian poles may be relatively new, speculation that water existed there became common more than a century ago. And its implication that intelligent life could also exist on the red planet elicited widespread anxiety on Earth for much of the first half of the 20th century. Astronomers pointed the first telescopes toward Mars in 1610. As spyglass technology steadily improved, the blurred image of the red planet drew ever closer to the eyes of earthly observers. By 1877, telescopes could enlarge the image of the distant planet so that it appeared roughly the size of a dime held at arm's length. Certainly not impressive by modern standards, but it was enough for the director of the Milan Observatory, Giovanni Schiaparelli, to attempt to sketch the Martian surface and name its geological features. Schiaparelli peered at the hazy, shifting visage night after night for months.
And he sees what he thinks are crisscross lines on the surface of Mars. Turns out later, what he saw isn't exactly what's up there, but still through his crude telescope, that's what he could see.
The respected Italian astronomer sketched these lines and gave them a name.
Schiaparelli interpreted these lines as channels of some sort. He didn't really know. Well, the Italian word that he applied to them was canali. That word, translated to English, should have been translated as channels, but instead it got mistranslated as canals.
Since straight lines do not normally appear in nature, Schiaparelli's sketches gave birth to the idea that some form of intelligent life must exist on Mars. It was an arresting notion, widely debated among astronomers of the day. Later, in 1894, a wealthy Bostonian named Percival Lowell was so intrigued by this possibility that he paid to have a large telescope constructed on a mountainside in Flagstaff, Arizona. He spent the next 2 decades observing, sketching, and speculating about the red planet.
He convinced himself that he was seeing networks of straight lines on Mars, which he thought were canals. What was the big news of the day? The Panama Canal. That's what great planetary civilizations do. They build canals. So this was canals to bring the water down from the polar ice caps. Mars was cold and far from the sun and dry, and so he knew that, and so he thought, well, I have to move the water to live on Mars. Well, that idea just electrified everybody, that there was a civilization on Mars.
Against this backdrop, on Halloween night 1938, a young actor named Orson Welles broadcasted a dramatization of War of the Worlds, a novella by British author H.G. Wells, in which sinister Martians land on Earth and wreak havoc.
We now return you to Carl Phillips at Grover's Mill.
Ladies and gentlemen, here I am. Wait a minute, something's happening. There's a jet of flame springing from the mirror and it leaps right at the advancing men. Lord, they're turning into flames.
Thousands of citizens believed the invasion was real.
You're deeply shocked and deeply regretful.
The misunderstanding was short-lived, but even so, the broadcast only served to fuel public speculation about potential intelligent life on Mars. Mars, it had intrigued humankind for thousands of years. And in the mid-20th century, humans finally got a closer look at the mysterious planet. In 1964, the National Aeronautics and Space Administration, NASA, launched a small exploration spacecraft toward the red planet. Its name was Mariner 4. It had a television camera, and its mission was to fly past Mars and send back pictures. It could only make one pass. Scientists were filled with anxious excitement at the prospect of what they might see.
Is it going to see cities? Is it going to see canals? Is it going to see forests? Well, what it saw was craters. It sent back pictures which just were very fuzzy and showed craters like on the moon.
It was a huge letdown. The Mariner 4 images revealed a dry, cratered, desert-like, and seemingly dead planet.
Sort of like the moon with a little air to blow the dust around.
But the enthusiasm for exploring Mars was only tempered. And 6 years later, in 1971, NASA sent another spacecraft to the red planet, Mariner 9. But this time, rather than just making a single pass by Mars, Mariner 9 was engineered to orbit the planet for weeks and do a complete mapping. The effort paid off. After waiting out a planet-wide dust storm, Mariner 9 started returning spectacular images. It discovered the Tharsis Bulge, the sort of potbelly of the planet near the equator. The bulge is a result of concentrated and massive volcanic activity. The dominant feature of the Tharsis Bulge is the monster volcano Olympus Mons.
Olympus Mons is about the size of Missouri. If you put it in the middle of the U.S., it would dominate that picture. If it had a major eruption, a volcano of that size would probably fill up one state on every side of Missouri. So my hometown in Iowa would be under lava. Interestingly, it's composed of, we think, 3 separate volcanoes, or at least it's erupted in 3 different ways. If you fly over the top, you see 3 separate calderas. So it isn't just 3 times larger. This is a monster geological event. But in fact, if you were on the edge, the slope is so gradual and the peak is more than 100 miles away that you would know that it was a volcano. It's that massive.
And Olympus Mons is not alone. A few hundred miles southeast of the mountain stands a diagonal row of 3 other evenly spaced enormous volcanoes, each larger than any of its type on Earth. Yet, as magnificent as it is, the Tharsis region isn't the only spectacular geological feature discovered by Mariner 9. At the eastern edge of the bulge is a colossal tear in the crust of the red planet. It's called Valles Marineris, Mariner Valley, in honor of the Mariner 9 orbiter itself.
You look at this thing, it is like the width of the United States. It's this cleaved valley. You know, the Grand Canyon in the United States? Pump it up, put it on steroids, make it the size of the United States itself, you got Mariner Valley.
The geological mechanism that caused this immense rupture in the Martian surface is yet a mystery. Scientists can only speculate.
One mechanism which I like is that there's a place called the Tharsis Bulge not far away, in which so much lava and other things have accumulated that it's felt it could put a giant torque on the surface of Mars and pull this apart like a zipper. Well, who knows if that's true, but one needs a mechanism different from anything that we know to explain the existence of that.
With the stunning success of Mariner 9, the next logical step for NASA was to land a spacecraft on the actual surface of Mars. Scientists were eager to test rock and soil samples for signs of life. In 1976, the Viking mission reached the planet to do just that. It had both an orbiter and a landing component, equipped with robotic test instruments.
And we get right down on the surface and we scoop up some soil and we don't find a thing. Mars looks like a cold, dry, dead place.
But while the Viking lander toiled away on the ground, failing to make headlines, high above the Martian surface, the Viking orbiter managed to capture a mystifying image. While flying over a region of Mars called Cydonia, the orbiter snapped an image of a land formation under cross-lighting. Startlingly, the formation resembled a human face. As a joke, NASA scientists showed the photo to the press, remarking about the face they'd found on Mars. Under more even lighting conditions, of course, the Martian terrain feature does not look like a face at all, just a jumble of hills. But in certain circles, the story of the face on Mars and its NASA cover-up persisted for several years. True Mars enthusiasts, on the other hand, faced a more sober reality following the Viking mission. With no definitive evidence of biology resulting from the Viking experiments, interest in returning to the Red Planet quieted for several years. Then, in 1984, a young scientist on an expedition in Antarctica made a discovery that ultimately infused new energy and hope into the quest to uncover life on Mars. In December 1984, NASA geologists on a meteorite gathering expedition in Antarctica found an odd specimen. A meteorite with an unusual color, a sort of green hue. Most are gray or brown. Back at NASA's Johnson Space Center in Houston, where such rocks are stored, it was labeled ALH 84001. Despite its odd color, the scientists assumed that it was a piece of an asteroid.
So the rock was pigeonholed into a group of meteorites, and it stayed there for 6 or 8 years. Misclassified.
Then, in the early 1990s, an analyst researching asteroids placed a piece of ALH 84001 under an electron microscope. He soon realized he was not looking at a normal meteorite. He was looking at a piece of Mars. The rock had characteristics that matched another Martian meteorite found in 1979. More scientists began studying this sample, and they were astonished when they eventually found what looked like carbon globules. Carbon, at least on Earth, is the primary building block of life. Senior scientist David McKay headed up the research group.
My imagination was ignited by the carbonates. And I said, hey, these carbonates are really strange looking. How do they form? Let's look at those.
Closer scrutiny of the rock sample brought even more startling discoveries.
The kind of chemistry that went on in those globules is associated with life on Earth.
At least one scanning electron microscope image revealed a structure that looked suspiciously organic, almost like a worm. Could it be a trace of primitive Martian biology?
I think that worm is biologic. Whether it's a complete fossil of bacteria is problematical. It could be a part of a bacteria.
Whew. You guys meet? Greg, Janice?
We sure did.
That was stupid.
Great.
This is Smart, a beeper service for just $1.99 a month. From who else? Smart Beep. Call 1-800-BEEP-199 for other smart stuff, like directions.
We've got chemistry here. You feel it?
I felt it.
Could be a section of one, but it's biologic in my view.
I'd like to welcome everybody here today. It's an unbelievable day. It's very, very exciting for me.
Finally, in 1996, after more than 2 years of study in which they had built 4 independent lines of evidence, the team was ready. They announced their hypothesis. ALH 84001 contained possible evidence of past life on Mars.
We conclude that this is evidence for early life on Mars.
NASA held a major press conference, but not everyone was convinced. Labs across the globe requested samples of the rock to conduct their own analyses. In the end, after months of, at times, acrimonious debate, the consensus was that there was no consensus. Papers were published in support of the claim, but many more were published debunking the idea.
If I could have the first slide, please. The features that you see may be any number of things. For example, they could...
Many researchers are convinced that the formations in the rock that appear to be signs of Martian life were actually caused by mineral activity.
The majority of people would say that there is no relic biogenic activity in this meteorite from Mars. Dave's initial hypothesis was incorrect. I would say at this point that that's too simple a hypothesis to take. I don't think the work has been completed to a satisfactory endpoint to say either way.
Work on the meteorite is continuing. But even if researchers never confirm that the rock contains signs of Martian life, the ALH 84001 episode has already completely reinvigorated interest in the quest for life on the red planet. Ironically, the new push to find life on Mars has often led scientists yet again to the continent of Antarctica. Conditions in this part of the world are analogous in many ways to conditions on Mars. Seeking out life forms that manage to thrive in extreme circumstances here might shed light on how and where primitive life could have once taken hold on the red planet. One environment astrobiologist Dale Anderson focuses on is at the bottom of lakes, covered year-round with thick layers of ice.
Most people said that because of the thick ice covers, you would find nothing but rocks. There would be very little to nothing on the bottom.
The ice layer sealing off many of these lakes is up to 15 feet thick, but rather than trying to blast or drill through it and disturbing the ecosystem below, Anderson and team have found a much less damaging approach. They let a massive coil of copper tubing make an opening.
Then you just pass a hot liquid through it, throw it out on the ice, and let it melt its way down. It takes about 24 hours. It melts through the ice, and then we've got this very nice, clean hole to dive through.
Divers enter the water wearing full-body dry suits. And what they find at the bottom of nearly every Antarctica lake bed is a testament to the stubborn tenacity of life. Mats of microbial organisms are thriving in frigid environments that receive virtually no sunlight.
Most people thought that if you had less than about 1% of the surface light, you wouldn't have any photosynthesis taking place down on the bottom. They wouldn't be able to use enough light to live. It's turned out that they can photosynthesize with light levels down to 1/10 of 1%.
For Anderson and his team, the pristine mats are truly a window to the past.
There are no higher organisms, no fish, no insects, no animals creeping through it. So these microbial communities have the opportunity to grow by themselves without interference from other animals or plants. And that gives them the opportunity to grow in very special ways.
Is it possible that a similar form of microbial life could still reside somewhere beneath the frozen surface of Mars? Especially at the hydrogen-rich poles? Anderson and scientists like him believe it is worth investigating.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
In the summer of 2003, NASA's Jet Propulsion Laboratory delivered 2 exploration spacecraft to the surface of Mars. Missions to the Red Planet are only feasible once every 2 years during a specific short window of time. The launch must be timed so that the spacecraft and Mars arrive at a specific point in the planet's orbit at the same time. The journey across the 34 million mile distance can take up to 7 months, and the trajectory must be perfect.
The accuracy required to go from Earth to Mars and to hit the spot you want to be at on Mars is equivalent to shooting a basketball from Los Angeles to New York and have it go through without hitting the rim, nothing but net.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing at the Gusev crater in the southern hemisphere of Mars. Current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds. Parachute lift detected. Expected retro rocket ignition on my mark.
The spacecraft were actually rovers, robotic vehicles capable of traveling across the Martian surface and poking around.
The rovers are robot geologists. Their job is to be our eyes, our feet, our hands on the Martian surface. We experience Mars through them. They can reach out and they can touch rocks. There's this device called the RAT, R-A-T, the rock abrasion tool, which is a diamond tip grinding tool that we can use to grind into the interior of a rock, and so we can actually get a window inside the rock. They have sensors on the end of that arm, like there's a microscope for telling us in detail what they look like. So we've got a whole bunch of tools similar to what a geologist would want if they were actually physically there on the scene.
The rovers were named Spirit and Opportunity, and they are still exploring regions of Mars today at locations on the planet hundreds of miles from each other. Spirit landed in an area dubbed Gusev Crater. The crater is believed to be a dried-up lake bed, so if the water it once held contained biology, Spirit might uncover signs of it. Opportunity touched down in a region called Meridiani Planum. The area is intriguing because it contains an ancient layer of hematite, an iron oxide that on Earth usually forms in a spot that held liquid water. So far, neither rover has found signs of life. But both Spirit and Opportunity have uncovered ample proof that liquid water was once plentiful on the surface of the Red Planet.
We've seen places where water soaked the rocks beneath the surface. We've seen places where water came to the surface and flowed over the Martian surface, creating little ripples that are still preserved in the rocks billions of years later.
But neither rover is close enough to the tundra-like Martian poles to uncover actual frozen H2O. That is the primary goal of a new mission to Mars, launched in the summer of 2007. This mission is dubbed Phoenix, and its plan is to place a stationary lander in the region of the Martian North Pole. The lander has a sturdy robotic arm equipped with a scoop. Phoenix will excavate the polar soil. Dr. Peter Smith of the University of Arizona heads up the project.
Our entire scientific mission is about understanding the properties of the soil and its interaction with the ice, and the properties of the ice and the ice interaction with the atmosphere. We have only one way to study it, and that's by using our robotic arm as our backhoe, if you like, that's going to dig a little trench and provide samples of both soil and hopefully wet soil, if we can find it, and ice. And we will analyze those samples with instruments on the deck of our spacecraft.
The lander will beam signals back from the Martian surface, reporting the results of the remote soil and ice analyses. But before Phoenix has even had a chance to make it off the launch pad, a new wrinkle in the saga of water on Mars has revealed itself. Images beamed back from a spacecraft currently orbiting the red planet show evidence of a very unexpected event. It appears that a liquid flow of some sort has occurred within the last few years in a small gully at the edge of a deep Martian ravine. In 2001, the orbiter took photos of the exact same spot, but nothing of interest showed up in those shots. The new photos, on the other hand, showed a white residue in the gully, a residue seemingly left behind by a flow of liquid, possibly where water spurted from the ground and flowed for several hundred yards before transforming into vapor and vanishing. Scientists do not yet understand what might have caused such a flow, but many suspect that it's a result of some form of internal heat the planet must still contain.
Clearly, it's a planet that's been volcanically active. And all of us are very hopeful that some places on Mars we could find hydrothermal vents. And not just because we want liquid water, but because the liquid water implies that this might be an environment that life could develop or be maintained.
It is, of course, all about the search for life. When all is said and done, the engine driving all of the astonishing scientific effort to explore the red planet is the burning desire of humankind to know if life exists elsewhere in the vast reaches of space.
I think humans have, since the dawn of consciousness, wondered why they're here, and wondered what's up there, and wondered if there's more. And answering that question will sort of put us in some kind of perspective. It'll tell us what our place is in the universe to some extent.
Finding life on Mars could also help us understand the origins of life on our own planet.
And there could actually be, in the case of Mars and Earth, a significant connection. You know, if Mars developed life itself, maybe the conditions were right on Mars, but they weren't right on Earth. But yet Mars seeded our planet. Perhaps through meteoritic collisions, pieces of Mars arrived on Earth. With cells of life, and that actually grew here. Maybe we could all be Martians. Or perhaps it was the reverse, you know, perhaps life originated on this planet and moved to Mars.
If we find evidence for life on Mars, and we know there's life on Earth, of course, then there's probably life all